This lecture is about thinking, the basics, and all the fun stuff like decision making and problem solving. In this lecture, you'll learn about the definition of thinking and the basic foundation of thought. Then I'll discuss decision making and its related theories. Finally, you'll learn about problem solving and different types of thinking. Thinking is usually viewed as the manipulation of information mentally, and it involves forming concepts, making decisions, solving problems, and reflecting critically and or creatively. You might recall that language is a system for communication. In the past, it was believed that we speak what we think, that language was simply a means of expressing thought. Although language and thinking are interrelated, as suggested by the linguistic relativity hypothesis, which states that language shapes the nature of thought, recent research suggests that, to a certain extent, thought and language are separate. Most researchers will agree that chimpanzees taught sign language can communicate, but few will assert that their ability to sign reflects much beyond surface-level thinking. They can communicate hunger or even feelings like sadness or excitement, but the degree to which those communications are tied to mental concepts and the complexity of such concepts is much less clear. We use concepts as frameworks in our thinking to help organize and interpret information. Concepts can be used to group or categorize shared features of related stimuli or to represent abstract ideas like sympathy or love. We have concepts for anything from birds to fruit to college. They allow generalizations and inferences. For example, your concept of fruit may not yet contain lychee, pictured here on the right. But if you were to encounter one, you would relate it to your current concept of fruit. We also use concepts to form associations. For example, associations between fruit like an apple, an avocado, and a lychee might lead you to conclude lychee, like apples and avocado, grows on trees and contains seeds. Concepts also aid memory, decisions, and reasoning. Knowing the concept of fruit and then relating lychee to other fruit can help you remember its name and where to look for it, and how to behave when presented with it. Relating lychee to your concept of fruit can lead you to the decision to eat it rather than throw it away, or it can lead you to a reaction of feigned interest rather than shock and disgust because of the way it looks. As another example that combines all of these features, take your concept of high school, where you probably learned how to study and take a test. This knowledge can aid your preparation for college exams when you generalize your study methods from high school to the college setting. And though tests in college might be more difficult, they are associated to tests in high school. And when you do discover differences, those differences can be incorporated into the existing framework for test taking more easily than if you were to try to create a completely different concept of test taking in the college setting. Finally, if you decided that you didn't need to study for tests in high school, you might initially reach the same decision in college. But if you receive low grades, your decision to study for tests in college could then change. There have been a few different models to account for how we form and maintain concepts. The most basic model is the family resemblance model, which states that items in the same category must share certain features but do not have to share all features, like the fruit at the bottom of the page. The next model we will discuss is the prototype model. With the prototype model, we compare new or novel information to information of a concept that has the most shared features. If you had never encountered a penguin before, but you noticed that it hatches from an egg and has a beak and webbed feet, you might compare it to the prototypical features of a bird to determine its category membership. It's possible that the prototype you are using for birds might be a robin. The prototype is the perfect example of the concept, And when we make comparisons to it, we can gauge the level of overlap. If overlap is sufficient enough to warrant inclusion into the category concept, then the overall prototype could change somewhat. For example, in this situation, it could change to include more penguin-like flightless birds. The second model is the exemplar model. With the exemplar model, we compare new or novel information to all information in the memory of a concept. Considering the penguin again, if you were to encounter it for the first time, rather than compare it to some perfect representation of a bird, you would be comparing it to every bird you have ever encountered. For example, you could compare it to a robin, an ostrich, a canary, a duck, etc. If you find enough shared features among these comparisons, you could then decide to incorporate penguins into your concept of birds. The use of these models is not necessarily a conscious process. Often we make connections and expand concepts without even realizing it. But there is neural evidence to distinguish between prototype and exemplar theories. The left hemisphere and visual cortex are primarily involved in forming prototypes. In the right hemisphere, prefrontal cortex and basal ganglia are mainly active in recognizing exemplars. Neuroimaging techniques show that we use both when forming concepts and categories. As a particular type of thinking, reasoning is defined as thinking aimed at transforming information or beliefs into a series of steps to reach conclusions. There are two forms of reasoning: practical reasoning, which involves figuring out what to do or reasoning directed toward an action, and theoretical reasoning, also called discursive reasoning, which is reasoning directed toward arriving at a belief. If you see dark clouds overhead and lightning cutting through the sky, you might engage in practical reasoning to seek shelter, and theoretical reasoning to conclude that it will rain at any moment. With the more complicated reasoning, you'll find that people's judgments about whether to accept conclusions often depends more on believability of the conclusions than whether the arguments are valid. This is known as belief bias. Now, in the previous example of seeing dark clouds, the actual act of seeking shelter or deciding what action to take involves decision-making, problem-solving, and critical and creative thinking, because reasoning does not include any action that's oriented toward a goal. It is only a thought process. Decision-making involves an evaluation between two or more alternatives and then choosing among them. We're making decisions constantly, from what to eat to what to do. When we wake up in the morning, we're faced with the all-important and somewhat challenging decision to get up when the alarm goes off, or to hit the snooze button and stay in bed longer. Decision-making research continues to grow and expand. One of the initial theories proposed to explain how humans decide was the rational choice theory. When that proved to be problematic, heuristics and biases and prospect theory appeared as alternatives to describe human decision-making behavior. Rational choice theory states that humans make decisions by determining the likelihood that something will occur, judging the value of the outcome, and then multiplying the two to determine gains. The decision we make is based on the alternative with the highest gains. Sometimes, though, we have trouble determining the likelihood that something will occur, and the value of the outcome is not always clear. Now, rational choice theory assumes that if all information is available, then we as rational agents will choose correctly. But even then, this assumption is much too tenuous. In fact, Tversky and Kahneman in 1974 challenged the notion that humans are by nature rational agents making rational decisions by pointing out some of the common errors in human reasoning. They then offered reasons as to why we make such errors and called them heuristics and biases. Heuristics are fast and efficient strategies that facilitate decision making, but do not always ensure an accurate solution. They are often likened to mental shortcuts, and just like any other shortcut, they can help you arrive at your destination, or they can delay you even further. In order to exemplify one such heuristic, the representativeness heuristic, I want you to consider a random sequence of coin flips with a quarter. Think about which of the following patterns of flips is more likely to appear with a random sequence. Pattern 1, pattern 2, and pattern 3. So, which set appeared to be the one from the sequence of random coin flips? Most students would choose the first set because it aligns with their notions of a 50% chance of a flip ending in a head or a tail, and it has an ordering that aligns with their notion of randomness. The set on the page here seems less random because only once did the head appear. In 100 coin flips, you will likely find around 50 heads and 50 tails. But in a series of 6 flips, a localized sequence of flipping, the chances are the same that you would see any one of these 3 sets of coins. This kind of misconception about chance has led people to believe that after a long run of red on the roulette table, that black is now due. The idea is that deviation in one direction, the run of red on the roulette table, is bound to change in the opposite direction. Thus, the representativeness heuristic, which involves making a probability judgment by comparing an object or event to a prototype of the object or event, consequently suggests that we are insensitive to prior probabilities and have misconceptions about chance. Now let's pretend that this is not the actress Tina Fey. I know it is, but let's say that this person is actually named Linda. Linda is invariably helpful. She's single and very bright. In college, she majored in philosophy and math. And as a student, she was deeply concerned with issues of discrimination and social justice. And she also participated in animal rights demonstrations. Which description of Linda is the most probable? A. Linda is a bank teller, or B. Linda is a bank teller and is active in the feminist movement. When deciding which option is more probable, there are 3 probabilities to consider. The probability that Linda is a bank teller, let's say that's 20%, and the probability that Linda is a feminist, let's say that's 10%. And also the third probability that Linda is both a bank teller and a feminist, which is actually equal to the probability of the joint occurrence of the 2 previously mentioned probabilities. The joint occurrence can be found by multiplying the first by the second to get 2%. So the likelihood that Linda is a bank teller feminist is 2%, which is much less than the probability that Linda is a bank teller or that Linda is a feminist. The combined probability of events is always less than the independent probability of one event. However, many participants will choose description B. Why is that? If we started adding attributes to describe Linda, people often fail to understand that with more pieces of information, the probability of them all being true will decrease rather than increase. Thus, the availability heuristic states that the items that are more readily available in memory are judged as having a higher likelihood of occurrence. After hearing about Linda's interests and exploits in college, the notion that she is a feminist seems quite reasonable and likely. However, people fall for the conjunction fallacy when they think that the likelihood of any 2 combined events is greater than either of the individual events. Prospect theory is a relatively recent theory in decision-making. The idea behind prospect theory involves what economists and psychologists term expected utility. Expected utility takes into account the potential gains and losses and incorporates aspects of certainty and risk into decisions. Prospect theory states that people seek risk when evaluating losses, but avoid risk when evaluating gains. Consider a prospector at the turn of the 20th century. These were individuals who would search for minerals, fossils, or precious metals. If a prospector was told that he had a 20% chance of finding gold worth $10,000 on his plot of land, or was told that he could sell his land to you outright for $1,000, which do you think he would choose? Research on the certainty effect shows that he would be more likely to give up the land for the certainty of money. Although in reality, the expected value of the land is twice as much as what he would get for it. So you take 20% and multiply it by $10,000 and you get $2,000. So the expected utility is $2,000. In this case, his perception of the certain $1,000 had greater expected utility than the uncertain chance to make $10,000. But if you took that same prospector and told him that investment in a piece of land would have a 20% chance of costing him $10,000, or he could pay you $1,000 to help manage his land without further investment, he would reverse his previous decision and choose to gamble on the big loss. A really interesting application of prospect theory comes from research on the endowment effect. If you were given a mug worth $3 and then placed in a situation where you could either keep or sell that mug, how much would you sell it for? In most cases, participants placed in this very situation demand more than $3 to sell the mug that they were given. But buyers, on the other hand, would typically want to purchase the mug for under $3. Thus, the endowment effect refers to the tendency for individuals to overvalue an object in their possession. Prospect theory accounts for the endowment effect with loss aversion. It suggests that buyers and sellers evaluate the mug in a domain of gain or loss, respectively. These are based on their initial reference points. Sellers already have the object in hand, and so the sale of the object is viewed as a loss. Buyers do not have anything, so the purchase of the object is viewed as a gain. According to prospect theory, losing the object appears more costly than the cost needed to gain it. Problem solving involves finding a way to attain a goal when the goal is not readily available. It entails the following 4 steps: finding and framing a problem by recognizing what the problem is and considering it in a way that permits a solution. Developing strategies to obtain a solution using subgoals, algorithms, or heuristics. The evaluation of the solutions by judging how well they worked. And finally, rethinking and redefining problems and solutions with questions like, can one solution be improved? And are there flaws in the solution? The 2 processes commonly used to solve problems include means-end analysis, a process of determining the steps to reduce differences between the current state and the desired goal, and analogical problem solving, where the solution is obtained by finding a similar problem with a known solution and applying it to the novel problem. Consider the following problem. Martha and Marjorie were born on the same day, in the same month, in the same year, to the same mother and father, yet they are not twins. How is this possible? Think about the question as we discuss the concept of insight. Some solutions to problems involve insights. An insight describes the spontaneous restructuring of a problem or the unconscious incremental processes. Insight often requires one to reconstruct the problem in order to overcome framing effects caused by things like functional fixedness. So in reference to the previous question, what are some potential framing effects? Perhaps that only two individuals were mentioned, along with the statement, not twins? Are there any other cases in which babies are born at the same time other than cases of twins? Maybe overcoming the functional fixedness and restructuring the problem allowed you to gain insight to one possible solution. That Martha and Marjorie are two babies in a set of triplets. Finally, two skills that are related to superior problem solving and decision making are critical thinking, that is, reflective and productive thinking that evaluates all evidence, and creative thinking, thinking about something in novel ways and in unusual ways that result in unconventional solutions. Critical thinking is achieved by remaining mentally alert and using consideration rather than acting automatically or impulsively when approaching a problem. It also involves being open-minded or receptive to other ways of looking at a problem or possible solutions to avoid fixation. Creative thinking is achieved with divergent thinking, thinking that produces many different solutions to one problem. That is what might happen in a brainstorming session. And convergent thinking, which involves evaluating the many different solutions and determining the single best solution. In summary, the basics of thinking involve frameworks for mental representations called concepts. Thinking is involved in reasoning, decision-making, and problem-solving. Decision-making has been described at times as rational and at other times as subject to biases, infallible mental shortcuts called heuristics. Problem-solving involves two general methods for solutions and requires that the solver often overcome issues related to fixedness or other obstacles. Critical and creative thinking can assist in this endeavor.